Greetings, student. This is a recording of one of Garnett's online math lesson classes. You have been granted access to watch this video because you're a paying student and I have seen it fit to provide this recording to you. However, it is important that you know you're not allowed to share this video with persons outside the lessons. This policy is so that my services are kept only to my students. Thank you, and I do hope you enjoy and learn from this video.
Base questions. By now, you would have guessed it's conversion units of speed. And after spending the 15 minutes, I assume that you were able to answer all the questions. All right, so we're converting 18.9 kilometers per hour to meters per second. We know, and you can't forget that 1 kilometer is equal to 1,000 meters, right? And usually kilo is 1,000, right? Or 10 to the third. And we have 1 hour is equal to 3,600 seconds. Or if you want 60 multiplied by 60, right? So we're converting 18.9 kilometers per hour to meters per second. Need to use these conversions, and to use them, we'll apply them in our conversion factors. Now, I will not, of course, this is maths. This isn't the only way to do it. Some of you might go ahead and just divide because you know you have to, and multiply because you know you have to. But the conversion factors are one easy way of, as I said before, is one easy way of doing this. It can work 100% of the time once you know what you're doing. You can't go wrong if you do this, right? So the first thing I notice is I'm going to convert kilometers to meters and hours to seconds, right? That's how we change between, we convert speed unit to speed. We're converting one unit to the other and the other to the other, right? Hours goes to seconds and meters goes to kilometers goes to meters, right? And we need to, of course, the conversion factor would be 1 over 1,000 or 1,000 over 1. Where does the 1,000 or the 1 go? Depends on our what you want to make that, what we want to convert, right? So kilometers is in the numerator, so the 1 kilometer will go in the denominator in our conversion factor, and the 1,000 meters will go in the numerator for our conversion factor. We apply the same concept when we're looking to convert hours to seconds. We know it's 1 hour over 3,600 seconds. The hour is in the denominator, so in our conversion factor, the hour will be in the numerator, and the 3,600 seconds in the denominator. So we have our conversion factors now, and we know if we're dividing hours and multiplying hours in the same expression, they'll just cancel each other out. Same with the kilometers. If you're multiplying, right, we're multiplying kilometer and dividing kilometers, they'll just cancel each other out, and we just do the math with the numbers, right?
5 meters per second.
5.25 meters per second. We did it the other way. Well, that's incorrect. If you get this wrong, right, the 1,000 over 1 wrong, you get the entire thing wrong, right? So you need to ensure you get this part right. Yeah. You need to ensure you get the right conversion factors, right? Because if, right, same conversion, just new number, right? So we know it's 91.8 kilometers per hour. I'm writing it like this so you can see how the units cancel out, and it's 1,000 meters divided by 1 kilometer. Again, it's important to ensure that your unit in your conversion factor unit is in the denominator if it's in the numerator for the quantity that you're converting, right? And again, the conversion factor, we're going from hours to seconds, so it's 1 over 3,600. But we know the 1 hour needs to be in the numerator because it's in the denominator over there. That, yeah, and the reason for that, as I said last class, it's just so that the units, not last class, last week, it's just so that the units cancel out. Right? So it's 91.8 multiplied by 1,000 meters divided by 3,600 seconds, and we get
25.5 meters per second.
25.5.
25.5. Okay. Right. Next question. Good. So converting converting 5 meters per second to kilometers per hour. This is going to be a bit different because we're going in the other direction. So we expect our conversion factors to flip. Right. Good. So we're converting again meters to kilometers and seconds to hours. So we got to use these conversion factors, these conversions, right? And we can use them by simply putting them in the conversion factor form and multiplying them by our original units, what we want to convert, right? So 5 meters per second is going to kilometers per hour. We need to convert the kilometers to the meters to kilometers, sorry. And to do that, we multiply it by our 1 kilometer divided by 1,000 meters. And how do we know which needs to go in the numerator? Meters is in the numerator in our original quantity, so meters needs to be in the denominator in our conversion factor, and the 1 km will be in the numerator, right? Then we're going to multiply it by 1 hour over 3,600 seconds. And of course, same thing like before. The 3,600 seconds will go in the numerator because the seconds is in the denominator, and 1 hour in the denominator here. Right? Again, this is just so the units will cancel out and you get a nice conversion. So in this case, it is 5 multiplied by 1 over 1,000. 1 km over 1,000 multiplied by 3,600 over 1 hour. So what is this? The answer 6 times 5 is indeed 18 kilometers per hour. Okay, so it's 18. Right, double check. You get. Please ensure if this is confusing you, what you can do is instead of multiplying it like 1 over 1,000, and I figure some of you are doing it already. It's 5 multiplied. Well, it's multiplying, but the 1,000 is dividing, so you can divide 5 by 1,000 and then multiply by 3,600. Right, take your time and do it step by step. Or you could do the same up here. It's 91.8 multiplied by 1,000 and then divided by 3,600. Or just to remain the same, I'm running the space. And of course, that would be 40 meters over seconds. And we multiply by the same conversion factors. Right, the same orientation. Go to divide 1,000. Actually, I'm not seeing the bottom. Let me know and rewrite it at the top. 1,000 meters. Right, we know meters will go with meters and seconds with seconds. And what do we end up with here? Right, so this is our answer. Good. The last two, once this is question 3, wants us to convert 30 meters per second to kilometers per second. Right, and I said you won't usually see these units kilometers per second. It's usually meters per second and kilometers per hour, usually, right? You won't usually see these guys. One of the reasons why you didn't ask, but one reason why you won't usually see it is because of the conversions, right? Usually you want to stick the high units because meters and seconds are usually usually to have smaller unit of measurement for those for time and for time and distance. And while kilometers and hours is two high units for distance and time as well, right? Time is higher, time is a larger value in hours than it is in seconds. Not a larger value, it's larger, it's a larger quantity. I'm gonna say value because if you look at the actual value, might look smaller. Yeah, right. Time hours is more than seconds. Same with the meters. We're just going from meters to kilometers. I didn't write this back, so then you got to remember our 1 kilometer is equal to 1,000 meters, and 1 hour is equal to 3,600 seconds. Good. So we're looking at the units. It's just the seconds is staying seconds. It's just the meters going to kilometers, right? Kilometers. So simple conversion, we're just converting the meters to kilometers. So we're just going to use our one conversion, which is 1 kilometer is equal to 1,000 meters. I said before, how do we use the conversion? By using the conversion factor, and that is to multiply it by either 1 over 1,000 or 1,000 over 1. Now, meters is in the numerator, so of course it will be in the denominator for our conversion. Right, that's the only thing we're converting, so we just need to multiply with this, and we end up with, well, we can do this math in our head, right? So, and the last one asks us to convert 108 kilometers per hour, another funny conversion to kilometers per second, right? Again, the kilometers is staying kilometers, it's just hours going to seconds. So we just need to use one conversion factor, right? And that is our 1 hour is equal to 3,600 seconds. Yeah, that is a 1 hour is equal to 3,600 seconds. How do we use our conversions? We just use them as conversion factors and multiplying them by original quantity. So 108 kilometers per hour going to kilometers per second. We're just going to use our 1 hour over 3,600 seconds conversion factor. We know the 1 hour will go in the numerator because the hour is in the denominator in our original quantity, right? And the 3,600 seconds will go in the denominator. So that those two goes out, and we're left with nope. Please ensure you're using the right conversions. We'll mix up the two. 1 hour is equal to 3,003. Kilometers per second. This is what we got. Final answer. This is what we got for both. All right, so coming back from the break, let's look at, we're moving on to another topic in another section of the syllabus. And that topic is, that topic is frequency and cumulative frequency. They go hand in hand. And the section of the syllabus is statistics, right? Now, statistics, it's one of the most applied part of mathematics. Yeah, it's generally found in like almost every field, right? This is something you can find in almost every field, from medicine to science. Those are all science fields. I only know science fields that much. Oh my God. Anyway, there are fields other than science fields. So Statistics is one of the most applied part of mathematics. So so you will be using it in almost all your SBAs. I believe you'll be using some form of statistics in most SBAs and research and so on. So what I try to do is I try and explain. I'll try my best to explain what's going on. And what I try to do is help to see you guys try and correlate what you're doing in maths, particularly with statistics, and something that you might be doing for an SBE, right? So because like I said before, statistics is a part that shows up in most SBEs, right? You gotta do graphs, you gotta do tables, that kind of thing, most research and so on. So this is one of the most applied part of mathematics, the algebra and the functions and relations and so on. Yeah, you might not be using those as much as you will be using statistics. Again, it depends on which field you go in, right? All right, so frequency and cumulative frequency is where it starts. And there's what I'm going to do, particularly with this topic, we're going to go through what frequency is. Like I'm going to give you an introduction to what frequency is, what it's all about, relative frequency. What relative frequency is. We're going to also look at constructing ungrouped and grouped frequency tables. We can split data into grouped and ungrouped, or discrete and continuous, discrete and continuous. I almost forgot. Discrete and continuous data, right? And cumulative frequency, we're going to get into cumulative frequency and constructing cumulative frequency table. Now, frequency is not a difficult part of statistics. The difficult part comes when we're looking at those graphs, and mostly when we're looking at cumulative frequency, right? That's the most. I can tell you straight away that that part isn't going to be quite as easy as the others, right? Now, enough of that. I usually like to ask this question. I know what I'm dealing with. Right off the bat, what is frequency and what does it mean when you're talking frequency? So the frequency of an event. So when you're talking about frequency, you're talking about the frequency of something, right? Frequency usually doesn't stand alone. We're usually talking about the frequency of something. So the frequency of an event or an observation or score, these are all words that you might see being describing an event. Observation or score is defined as the number of times an event has occurred. That event in particular. Right? So the frequency of an event is defined as the number of times an event has occurred. It's just when you think frequency, think how many times do I see this observation, right? How many times does the observation occur? That's the question. That's what the question frequency answers, right? How many times does this observation, and we'll get into what is observation when I say observation, what I mean by that, just now, if you guys are following. So how many times this observation occurs, how many times a particular observation occurs. That's the question frequency answers, right? So for instance, for example, if a die is tossed 10 times and the results are 3, 1, 4, 6, 5, 2, 1, 3, 1, 5, right? We toss the die by that roll of dice, right? Roll the dice, right? We roll the dice 10 times and we wrote down how many, what it landed on, right? That's the example illustrated here. So we roll the dice 10 times and each time we wrote down what it landed on. First was 3, next was 1, next was 4, next was 6, so on, so on. Then we can say the frequency of 1 is 3, right? And remember, frequency is how many times an observation occurs. And what the observation is the observation is what you write down. And those of you that are in science, you know the observation is usually part of the lab report, right? That's what you see, right? So the observation is what you record. That's what are you recording, right? So we're recording the number it lands on. So the observation here is 3, 1, 4, 6, 5, 2, 1, 3, 1, and 5. Right? Well, the observation is just natural numbers. It's just numbers that are on the dice. That's the observation. Right? We're just observing what number on the dice that what number on the dice it landed on when we tossed it. Right? That's our observation. So what is the frequency of 1? And as I said, frequency answers how many times does the observation occur. So how many times between us tossing it 10 times do we see 1? And that is 1, 2, 3. It's highlighted in green 3 times. So the frequency of 1 is 3. What the frequency of 3 would be 2, right? We see 2 3 times. And since, yeah, that's basically it, right? That is it. And this is fundamentally what statistics gets into. You're looking at some observation, you're writing down how many times you see that. One way you can translate this to one of your SVs is questionnaires, right? You guys, we love to use questionnaires. I'm doing social studies and English and those SVs, maths even, right? And you want to know how many times a person put, I mean, don't use gender because gender is a controversial topic now. How many times a person answer yes or no to a question. That's the frequency, right? That's what we're going to call the frequency. I know maths is using fancy words to describe simple things, right? Frequency is just how many times did you say yes, a yes to whatever the question was, and a no, right? Let's say you give it to 20 persons, 10 answer yes, 10 answer no. That's your frequency for yes and your frequency for no. So it's how many times does the observation occur, right? How many times do we see that observation? By now, I think you guys get it. So that's what is brought out in this example. And you can go ahead and actually prepare a table with observation versus frequency. And that's what we're going to do. So that brings us to the last sentence, which says, a major way of organizing raw data is to a major way of organizing raw data is to put them in some sort of frequency distribution, that's a graph, or frequency table, right? Again, fancy words for simple things. I'm just referring to a graph and a table. You can either put it on a graph or put it on a table. That's what it means. When I say frequency distribution, it just refers to a graph. Don't let the fancy terms confuse you. Frequency distribution just refers to a graph, and frequency table just refers to a table, right? So we can take this information, and this is what we call raw data, right? Raw data. I should say this from the beginning, but when you write down, right, when you take your observation, you just write it down. You don't put it in a table. You don't do anything with it. This is what we call raw data, right? Most of us, we usually just go ahead and write our stuff straight into the table. So some of it don't even have raw data. It's still raw data, technically speaking, but it matches raw data. It's just the numbers laid out straight, just writing down the numbers how many times. We input it in a no table, we didn't put it in no graph. It's a raw data, right? Good. You're just taking notes, basically. Right? You can take the raw data, so we go down and put it in a table and then put it in a graph, right? So that's what this last sentence is talking about. We're taking raw data and putting it on a graph and putting it on a table. And we'll go through each one of these, right? Like I said before, we're looking at statistics. We're gonna have to do all of this. We're gonna look at raw data. I'm gonna take you through each form. We're gonna look at raw data, then we're gonna look at putting it on a table. We're gonna look at putting it on a graph so you can see the correlation and how statistics works. And then of course we have to interpret the graphs, right? We still gotta do that. That's a major part of doing SBAs as well, interpreting graphs, right? So we'll take our time to, let's move on to some actual examples, getting some raw data, putting it at the table. And we'll look at the graph stuff last, right? Because that's usually the one where you're gonna, we gotta go through a lot of stuff concerning graphs, right? Because you gotta be able to look at a graph, interpret everything that's going on with that graph, and come up with conclusions and so on, right? We will do a lot of that, and I will even take you guys to some real world examples. All right, so we've talked about frequency. Frequency is just how many times an observation occur, and what is relative frequency, right? So relative frequency is sort of like probability, right? I mean, get into probability even, but I don't think we'll get into probability this year. Next term, I'll look at probability, right? The relative frequency or experimental probability of an event occurring is defined as the frequency of the event in comparison to the total frequency. And this is probability, right? So think of relative frequency as probability because it actually is just another word for probability. So frequency has a lot of words with meaning some simple things. Right? So think as it as probability. Using the earlier example, I'll use back the same example I used just now. So just now, right? So simply put, this is how the frequency of one event is related to the total frequency of the event, right? How the frequency of one event happening is related to the total frequency of that event. What do I mean by that? Remember, event is an observation, right? Going back to the example with your questionnaire, right? With your questionnaire. I'm trying to come to an actual question. Do you like apples? Right? Yes or no. So we have an actual question. So do you like apples? Yes or no. You give out the questionnaires to 20 people and you receive back your questionnaires. You write down the raw data. So you have 10 persons that said yes. You give it all to 20 people. Remember, this 20 people. I'm just giving you guys some random examples, but we actually get into an actual examples as well. So what I just want to get this across. So 20, we give here the questionnaires to 20 persons. 20 persons answered the questionnaire. 10 of them answered yes, 10 answered no. So we have, for yes, we have 10, and for no, we have 10. But the total frequency, meaning the total, that is the total amount of persons that answered the questionnaire, right? The total amount of frequency. How many persons answered no, plus how many persons answered yes, which is 20. So the total frequency would be 20. And the frequency for yes is 10, frequency for no is 10. Hope you guys are following. So the relative frequency is just asking us or telling us the probability of yes and the probability of no, basically that, right? If the total is 20 and the frequency of yes is 10, then 10 over 20 would be our relative frequency. If the total for no, the relative frequency of no, right? You can have the relative frequency is for a particular observation, right? So the relative frequency is of an observation or event, right? So you're talking about a particular observation when you look at relative frequency. Right? So 10 over 20 would be our relative frequency, and we can express that as a fraction. And as it says right here, it's the frequency of the event, which for the example that I'm coming up with of the ball is yes, right? What's the frequency of yes? It's 10 divided by the total frequency, which is 20. And total frequency is usually how many persons you give the questionnaire to, right? And as a percentage, you can write it as the same relative frequency, which is the frequency of the event divided by the total and multiplied by 100% to express as a percentage, right? It's the same as probability, is the same thing as probability. Well, enough of that. What I need to get into is an actual example, right? All right, so that is relative frequency. That is frequency. Frequency is just the amount of time an observation occurs. A relative frequency is just the probability of a specific observation, right? You can express it as a fraction or as a percentage. Now, one thing to note is that that's not here is that relative frequency could either be, if you're expressing it as a percentage, it can only be between 0 and 100, right? You know this, right? You can't have something like, you can't get 120% on a test, usually, right? Usually, that's not possible, usually, right? Unless you're doing some weird math there, right? But so as a percentage, it could only be from 0% to 100%. But as a fraction, it could only be between 0 and 1. And for those of you who did probability, you should already know this, right? Relative frequency as a fraction could only be between 0 and 1, which means that is an actual fraction a proper fraction to be exact. Can't be an improper fraction, right? So it's between 0 and 1. The value for relative frequency can only be between 0 and 1. So if you're calculating relative frequency and end up with 1.5 or something like that, you went wrong. If you calculating relative frequency in percentage and you end up with 120%, it did something wrong, right? That's something that's not on the slide, and it's the same rules that apply to probability. So I will bring that up back when we look at probability. All right.